Okay, 1.1 is what is statistics? So first off, statistics is the study of collecting, organizing, analyzing, and interpreting data or information in order to make decisions. The individual in the study are people or objects included in a study, whereas the variable is going to be a characteristic of that individual to be measured or observed. For example, we are conducting a study of the people in your statistics class. So that means the individuals would be the people in your statistics class. Variables are going to be whatever you're studying about them. So maybe we're looking at their age, their year in school, their gender, something about those people. So in our study then, we would not include any data from people who are not in our statistics class, because we are only looking at those who are in the class. Now those variables we just talked about, there's two types. We have quantitative and qualitative. The quantitative variable has a value or numerical measurement for which operations make sense. So for instance, age, height, income, price. You can actually do math to those numbers. The qualitative variable is going to describe an individual by placing it into a category or group. So gender, color of clothes, zip code. So for these, you have groups or descriptions for the person, whereas quantitative is going to have a numerical value to it. Population data are from every individual of interest. We're going to have a population parameter then, and that's a numerical measure that describes part of the population. So you're looking at something that describes the population. For instance, we will see in Chapter 3, mean. So you could look at the population mean, or you could look at the sample mean. Sample is data that are only from some of the individuals, whereas your sample statistic is a numerical measure that describes an aspect of the sample. So a sample mean is only the mean of your sample, whereas the population mean is the mean of the whole population. So for example 1, we have the Hawaii Department of Tropical Agriculture is conducting a study of ready-to-harvest pineapples in an experimental field. They want to know what are the individuals and or objects of the study. So as we go through this, the individuals are looking at are the pineapples. So yes, there are more objects here, but the individuals are pineapples in the study. For part B, if researchers are interested in the individual weights of pineapples in the field, what is the variable of the study? Is this variable quantitative or qualitative? So they are looking at the weights of the pineapples in the field. Now, if you're thinking about weights, weights takes on a number, and we can actually do something with that number. So we could find the average, or we could find the range. We can actually find things with those numbers. So since it's numbers, it's going to be quantitative. For C, if the weights of all the ready-to-harvest pineapples in the field are included in the data, is the group of objects a population or a sample? Is the average weight of the ready-to-harvest pineapples a parameter or a statistic? We're looking at all of the ready-to-harvest pineapples. When it's everything out there, that's population. And since we're talking about everything, the average weight is only going to fit then the parameter, because the statistic goes with your sample. So it's going to be population, and that would be a parameter. Now for part D, if researchers are interested in the individual taste, poor, acceptable, or good, of pineapples in the field, what is the variable of the study? Is this variable quantitative or qualitative? So now what we're looking at is the taste, and it's a rating with the taste. So we're not looking at weights, we're not looking at numbers, we're looking at terms, descriptions. If it's a description, that's going to be a qualitative variable. So we're looking at the taste of the pineapples. And like I said, that's going to be a qualitative variable. So then for E, if only some of the pineapples are included in the taste test, is the group of objects a population or a sample? Is the proportion of pineapples in the group with a taste rating of good a parameter or statistic? Now again, we're looking at some of the pineapples. Some is going to tell you that's a sample. You're not looking at everything, you're looking at just the sample. Since it's a sample, that means we are going to have then statistic. Okay, so for this next one, what I want you to do is go through and answer the questions on your own. So hit pause on the video, try to go through these on your own without me, and then I will go through and explain what the answers are, because I want to see what you have gotten from what we did in example 1. Okay, so you should have your answers written down then. So we're going to go through this together. So television station QUE wants to know the proportion of TV owners in Virginia who watch the station's new program at least once a week. The station asks a group of 1,000 TV owners in Virginia if they watch the program at least once a week. They want the individuals and the variable. So for our individuals, we are looking at the 1,000 TV owners survey. Now, for our variable, we are looking at the response of does or does not watch the new program at least once a week. Then for part B, do the data comprise a sample? If so, what is the underlying population? We're only looking at 1,000 people. There are not just 1,000 in Virginia. So yes, it does represent a sample. And our underlying population would be all TV owners in Virginia. Now for C, is the variable qualitative or quantitative? So they're answering pretty much yes or no. So if it's yes or no, that means we're going to have qualitative for our answer. Then for D, they want you to identify a quantitative variable that might be of interest. So if we are surveying these different TV owners, you might want to know maybe their age or income. Those might be two things that might be important to look at as we go through this study. So maybe the age of the TV owner or the income of the TV owner. Now they want to know, is the proportion of viewers in the sample who watch the new program at least once a week a statistic or a parameter? So we're looking at samples. So that means any numbers from that group have to be a statistic. The next part of the section talks about levels of measurement. There are 4 of them. The first one is nominal. Nominal is where the data consists of names, labels, or categories. So you can put all the data into categories, such as gender, eye color, city. Everything fits in categories. Ordinal, the data can be arranged in order, but the differences between the data values are meaningless. So we can order the data from smallest to largest, or worst to best, like class ranking, rating scales, but it doesn't really help us if we say the 10th person in your class minus the first person in your class gives you 9 rankings in between it. So we don't really have a difference in between the two. We can rank things from first, second, third, and fourth, but subtracting the numbers is not going to get us anywhere. Interval. The data can be arranged in order, and differences between the data values are meaningful. So we can order the data and take the differences between them. So like years, degrees Fahrenheit, something we can subtract the two. So if we are looking at the year 2010, we know that is 6 years ago from 2016, because we can do 2016 minus 2010 and get 6. We've got ratio then last. The data can be arranged in order. Differences in ratios are meaningful, and there is a meaningful 0 value. So we can order the data, take differences, find the ratio. Now, for instance, with this, weight, degrees Kelvin, and pressure are ratios. Now, what's going to confuse you the most is this meaningful 0 value. So when you go through this, Fahrenheit and Celsius don't have a meaningful 0. We don't stop at 0. We can do negatives on both of those. So since there's negatives there, we don't really have a true 0, a true start and stop point. Whereas your age, you have a true 0. Money, we have a true 0. You can have no money at all. Anything that can have a true 0 to it, that can be done in ratio form. Degrees Kelvin is the only one that has the true 0. So that is the only measurement for temperature that we can use that's ratio. The other temperatures are going to be interval data. To determine the level of measurement, state the highest level that can be justified for the entire collection of data. So for example 2, we're going to see what categories these fall into. So for A, we've got 4 Native American pueblos from the population of all of the American pueblos in Arizona and New Mexico. Since those are just the names, that's going to be nominal. For part B, in a high school graduating class of 312 students, we have all these different rankings. Remember, rankings are going to be ordinal. Now for C, we're looking at body temperatures, degrees Celsius. Celsius right now should tell you that's interval. It cannot be ratio. And then for D, we have length. So you can have like 0 meters. You can have 0 centimeters. We can have 0 inches. So that's a ratio. So this is another one where I want you to pause the video, fill out these 4, and then check our answers together. Okay, you should have all of your answers written down. So we are looking at different data associated with a state senator, and we're trying to figure out which level of measurement it is. So first off, his name is Sam Wilson. So it's a name, so that's nominal. For part B, we have his age. Since age has a true 0, that's ratio. For C, we've got the years that he was elected. Remember, years are going to be interval. And then for D, we've got a leading news magazine claims the senator is ranked 7th for his voting record. If we have a ranking, that's going to be ordinal. Okay, remember, observations and analysis of a sample population are applicable only to the population from which the sample is drawn. So, for instance, if you make observations about a few students from the senior class, you cannot say those observations fit the entire high school population. It's only based off of what your sample is. Also, remember, depending on your sample, you could have different outcomes. So I could choose 10 people and then choose another 10 people, and we get different responses. So the sample might reflect the population, but you still might get some varying numbers and different answers from sample to sample. Descriptive statistics involve organizing, summarizing, displaying data in graph form. The data can come from a sample or population. We'll look at that in Chapter 2. Inferential statistics involve using sample data to draw conclusions about the population. This works when we don't have access to the entire population. We will look more at this in Chapter 7 and 8. We'll look at the population given information from a sample.